Good day, all. Today we are going to talk about factoring special products. If you remember from one of our earlier videos, we talked about several special products. The very first one we talked about was the difference of two squares, and that's where you had a squared plus b squared with no center term. So whenever you see a squared minus b squared, you know that this can be factored to a plus b times a minus b. If you'll notice that the plus and the minus here, when you do your FOIL or your distributive property, that you will eliminate your center term. Okay? Now, in that same video, we also talked about looking at perfect square trinomials. So our very first perfect square trinomial we looked at was a plus b squared. And the purpose of these patterns that we're looking at, our special products, is so that you don't have to do the distributive property or FOIL as you've learned before. That you can see this and you can see the pattern. If you ever see a plus b squared, you know that all you have to do is square the first term, square the last term, okay? Your signs will be positive, and then the center will be 2 times whatever number is in A and B, okay? So again, you square your first term, you square your second term, because this is addition, both your signs will be addition, and your center term will be 2 times the product of A and B, okay? Now, there is one other perfect square trinomial, and it is with a negative b. In this case, we have a minus b squared, and this one is going to be almost identical to the one above it. However, you're going to have a negative term for your middle term, and the second term or your b term is going to be positive as well. So the purpose of this video today is so that if you see anything in these patterns, that you know they can be factored back to their original perfect square trinomial or difference of two squares. Okay? So now that we've talked about that, let's look at one of our perfect square trinomials. So the very first one I want to look at, look at is 49m squared plus 14m plus 1. Now, we can look and see that this is a perfect square and our C term is a perfect square. They're both positive, so we know that we can factor this as to 7m plus 1 squared. Okay, so let's check to see if that is correct. And the way that I do this is I look at my A term and I look at my B term, I multiply them together and then multiply by 2, and if it equals my B term, my middle term, sorry, then I know that it is a perfect square trinomial. In this case, we're good. Okay, let's look at another one. How about x squared minus 4x plus 4. Well, my first term is a perfect square. My C term is a perfect square. We are looking at a negative here and a positive here. So I know that I need to use the A minus B squared pattern. So this is going to be x minus the square of 4 is 2. So we are x minus 2 squared. Let's check to see if this is correct. My A term is 1. 1 times 2 is 2. Negative 2, sorry. And negative 2 times 2 gives me 4. So it matches my center term. So I know that I factored it correctly. Okay? Let's get a little bit harder. Let's add in a fraction. How about y squared plus y plus 1/4? Well, y squared is a perfect square. 1/4 is a perfect square. So and we have both of these are positive, so we know we're going to use the a plus b squared. Well, y squared, the square root of y is square y. The square root of 1/4 is 1/2. And so we have y plus 1/2 squared. We check our work. A is 1. 1 times 1/2 is 1/2. 1/2 times 2 gives me 1y. So I got it right. So now let's look at the difference of two squares. Let's look at x squared minus 25. Well, I have no center term, so I know that I need to look at my difference of two squares. And if you don't remember, the difference of two squares is going to be a plus b times a minus b. And that looks like a squared minus b squared. Well, this looks like a minus b squared, or a squared minus b squared. Our first term is a perfect square. Our c term is a perfect square. So I think we can go ahead and write this as x plus 5, x minus 5. Okay? And let me show you. Let's check our work to see if we do this. Let's FOIL. Well, x times x gives me x squared. X times negative 5 gives me negative 5x. 5 times x gives me positive 5x. And 5 times negative 5 gives me negative 25. These two cancel each other out. So we're left with x squared minus 25, which is what we started off with. So we know that this is the factor of that. Let's look at another one. Let's look at 81c squared minus 4. Well, our first term, 81, is a perfect square. Our 4, our last term, is also a perfect square. What is the square root of 81? Well, we know that the square root of 81 is 9c, 9c. We know we have no center term, so we know we have to have a positive and negative. The square root of 4 is 2 and 2. So if we squared this or we FOILed this, we would get 81c squared minus 4. Okay? Now, let's look at something a little different. Let's look at a question like this. So let's look at this problem or this example. Now in this example, neither one of our terms are perfect squares, but I don't want you to give up there. Ask yourself, can I factor something out of these two numbers, or do they have something in common that I can pull out or factor out that will leave me with perfect squares? Well, me being a math nerd that I am, I know that 72 and 32 have a factor of 8. So I'm going to factor out 8. Well, 8 divides into 72 9 times. 8 divides into 32y squared, 4y squared. Look, we now have two perfect squares. Okay, so we can now factor this using the difference of two squares. Okay, do not throw your 8 away. So we now can break this down. Well, the square root of 9 is 3 plus 3 minus the square root of 4y squared is going to be 2y and 2y. And so we've now factored this. Okay? Let's look at another one. How about we look at negative 9r squared plus 4s squared. Okay, so let's ask ourselves, is our first term a perfect square? Well, 9r squared is a perfect square. 4s squared is also a perfect square. There's no center term, but this doesn't match our pattern. We have a positive here. So we can't have a positive times a negative to get us a last term like that. So, but I'm not going to give up. I'm not going to give up because I notice that my first term is negative, so I can actually factor out a negative 1. So let's factor out a negative 1 out of this problem. So I'm going to pull a negative 1 out. That's going to give me 9r squared minus 4s squared. And now we match the difference of two squares pattern. So we can now factor this. Negative 1, I'm going to make my 2. We know 1 is positive, we know 1 is negative. What is the square root of 9r squared? Well, that's 3r. And the square root of 4s squared is going to be 2s and 2s. And so we are now done factoring that problem. Okay, let's look at another one. Okay, let's look at negative 3y squared plus 36y minus 108. Well, let's ask ourselves, none of those are perfect squares. Our first term isn't a perfect square. Our last term is not a perfect square. But can we factor something out? So I'm looking at these three, and I think that we can take out a 3. I'm going to actually take out a negative 3. So let's see, negative 3 divides into 3y squared, y squared times. Negative 3 divides into positive 36y, negative 12y times. Negative 3 divides into 108, or negative 108, positive 36 times. And this looks like our A minus B pattern. So we are going to go ahead and try to factor this. So let's pull out negative 3 times y minus the square root of 36 is 6. And so there we are factored. Okay, I hope you've enjoyed this video. If you have, please hit subscribe and like below and follow our page. Thank you very much and have an amazing day.